Good morning, everybody, and welcome to iDAC and welcome to the high-rise pavilion. So we are going to be introducing Rahul as the wind RWDI wind energy experts. Rahul is a specialist and contributed insight and analysis to some RWI's most notable projects around the world, including the groundbreaking Hudson Yards development in New York City and the Vrindavan Chandrodaya Mandir, the world's tallest temple. In addition to this, to his specialized technical and project capabilities, Rahul has focused an effective style of leadership that helps his clients around the world. Let me welcome Rahul to do the presentation for RWI.
So a very warm good morning to all of you. I'm so glad and honored to be starting this session, especially when we talk about high-rise structures. I have a similarity with what Mr. Tak Matthews has. Like, we both deal with some unique areas which are very kind of predominant for high-rise structures. I'm dealing with wind, which is very, very crucial for the design of high-rise structures, and he is dealing with elevators, which we can't avoid for high-rise structures. So in this one, I'm trying to give you a glimpse of what are the type of studies that we do in wind engineering and how crucial they can be in the overall design of structures, especially when it's high-rise. So a little bit about my details. Like, I'm from a company called RWDI. Most of the people who have worked in high-rise buildings may be knowing RWDI because we are in this field for the last 50 years. Basically, RWDI is Rowan, William, Davis, and Irwin. Those are the four Canadian scientists who started this firm back in 1972, and we have been fortunate enough to be a part of most of the groundbreaking structures across the globe, including the current tallest building in the world. So if you look at the RWDI team, we have different people. We have engineers, climatologists, vibration experts, people from different fields, because wind is such a very unique field, which requires people from different arena to come and work together in challenging projects, which is very crucial for the design of high-rise structures. So if you look at our global presence, we have offices like on all parts of the world, and right now I am focused in the Indian office, which is in Trivandrum. And we have done projects across the globe in every part of the world, including Antarctica, and we have a lot of still research going on many high-rise structures and challenging structures, actually. So if you look at the service overview, even though today I'm going to talk only about wind, for RWDI, we have been having very specialized experts in all those fields, which is dealing with anything related to structures. We have wind, solar, daylighting, vibration, energy modeling. There are different fields of RWDI, and we have a very specialized expert team sitting in different parts of the world who are dealing with all these issues related to structures. And we have been fortunate enough to be the part of at least 95% of the world's tallest building. This is being published by the CTBUH, and RWDI has been the wind engineering consultant for most of the high-rise structures across the globe. And these are some of the iconic structures in our wind tunnel. You can see the scaled-down model of all those high-rise structures, which are being wind tunnel tested in our lab to understand how wind acting on these structures and how they can be designed properly. So these are the iconic projects across the globe. And if you look at India, we have been in business for last almost 12 years. So I have a big list of projects. So instead of showing all of them, I try to show them in locations. This is all the high-rises. I would say 95% of the high-rise buildings that you see in Mumbai are being wind tunnel tested by RWDI. So I'm just showing you the glimpses so you can have an idea about the kind of work that we are doing in Mumbai itself. So the question is, when it comes to wind engineering, why can't we still use codes or standards as what we have been using from a conventional method? Why codes and standards are not sufficient when it comes to wind, especially for a high-rise structures? So I hope most of you guys who have worked on high-rise buildings may have experienced these issues, like complex geometry, selection of terrain, because when you do a code calculation, you are assuming your building to be like a uniform, regular shaped structure. But in reality, none of the buildings are of regular shapes. It has all the complexities in types of shapes, terrain. Like we can't assume that it's going to be open for all the terrain. You have water features, suburban terrain, urban terrain, different terrains, and wind is passing through all those terrains before it comes and hits your structure. So you have to have a better idea about the terrain. Then directionality, from which direction wind is predominant for your structure. Basically depends upon how your structure is oriented and things like that. Surrounding structures keeps on changing. So how you are going to account that while doing the loading part. And then vortex-induced oscillations, which is one of the most crucial parts from an wind engineering point of view. So the final answer is still wind engineering is relying completely on a tool called wind tunnel, where we do all the wind tunnel tests to identify the loading on structures. So for people who are not familiar with wind tunnel is nothing but an kind of an long box with a big fan at one end, and on the other end you have your study building along with all the surrounding buildings on a rotatable disc, and the building will be having sensors which tries to understand the loading acting on your structure. So if you look at this one, your shape is being exactly replicated in the structure along with all the surrounding buildings, and the terrain will be taken care by the roughness sheet which you see on the picture. So that's how we do wind tunnel tests to identify how wind loading is acting on your structure. I'm just showing a couple of wind tunnels of RWDI in different parts of the world. The one is on the top is on the UK, where we can do 2 wind tunnel tests back to back, which are 2 test sections. The other wind tunnel on the top is Irvine Tunnel, which is like 7 meter wide, where we do most of the bridges and topographical studies and things like that. And the other 2 are like normal type of wind tunnels, where we do most of the high-rise structures. This is the RWDI's wind tunnel facility in Trivandrum, Kerala. Where you can see all these buildings are in Mumbai. All Mumbai projects, you can see different parts of Mumbai in all these projects. So this is a close-up shot of the wind tunnel in Trivandrum. So even though this is for like tall buildings, I just want to show one slide, but it's not only for buildings. Like recently we won the Pune-Mumbai Missing Link Bridge. So this is going to be the second bridge which will be doing wind tunnel test by our lab. Which is in India actually. We have done the Anjigat Bridge in Jammu Kashmir before. So bridges, memorials, skywalks, interesting roofs, stadiums, airports, all these structures are wind sensitive, and for the proper design of these structures, we have to know the exact wind loading acting on the structures, which is possible only through wind tunnel test. I thought it won't be fair if I didn't show you these ones, because these are again kind of very interesting projects that we are been working recently on, which is the current trend of statues. So a lot of statues are coming, which is like very challenging from wind engineering point of view for me. But again, these are the things that we really look forward to, because we can't do actual or apply wind engineering techniques like what we do for a normal high-rise buildings. It's very challenging from wind engineering point of view. So you can see all the Mumbai airport, the air traffic control tower, and the Lodha tower, and all those things. Now, getting into the studies. So the first study, which is very simple, is the cladding wind load study, where we are interested to know the pressures acting on your exterior facade or the cladding elements, so that the facade consultant can select the right kind of cladding elements for designing the structures. So the process is like, once we get the 3D model from the architect, we create our own 3D models on the computers, and then we create or 3D print the physical model using 3D printers, and then install sensors and do the wind tunnel test. So basically, if you look at, if you have a close-up shot at the models, it would be like this when you have balconies and stuff like that. And we measure pressures, instantaneous pressures across the balconies and things like that, to understand how the balcony guardrails and stuff like that, which are very wind sensitive, has to be designed. And based on the pressures from the wind tunnel, we try to give block diagrams like this. This is like a close-up shot of the elevation. And now it's showing like 2.25 kPa for one corner. So based on this, the facade consultant will choose the right kind of cladding material, or how the facade elements in those areas has to be designed. This is purely for the cladding part. Now, when it comes to structural part, we are interested to know the overall structural moments and shears and torsion acting on your structure. So which is purely very, very crucial for the structural engineer for design of foundation and all those things. So for that, we use normally high frequency force balance test. As you can see, I don't know whether this is like clear for you. There's a flexure which contains the strain gauges, and the building will be connected to the flexure, and we do the wind tunnel test, which will give you all the overall wind loads and wind induced motion, which is very crucial. Nowadays, most of the structures are being wind tunnel tested not for identifying the loads, but to make sure that the buildings are not moving excessively, which means it satisfies the serviceability criteria. So once we do the wind tunnel test, we get moments like this for all the 360-degree wind directions, and that will be clubbed with the wind climate data that we have obtained from the airport data. So when we do this clubbing process, that's when the wind tunnel test becomes very relevant to the site-specific project. And finally, we give the overall forces acting on your structure. So you can see both the moments on X and Y directions along with shears and torsion. Along with that, we also give the floor-by-floor loads, which is very useful for the structural engineers to plug back to your ETAPS model, from which you can calculate the deflection and stuff like that. And along with that, we also give the load combination factors, which is, again, very, very important, because that's where most of the time the savings part comes into picture. Because unless you use the right kind of wind combination factors, the loads are going to be conservative or on the reverse direction. So this is the plot for the accelerations. Again, like there are different acceleration criteria for different buildings depending upon the occupancy. So we try to find out where the acceleration values are for the specific building. And based on that, we try to give them mitigation measures. Now, the third interesting study is the pedestrian level wind study, where we are trying to identify the comfort of the occupants or the pedestrians around the building. This is the Microsoft campus upcoming in Hyderabad, which is not like a high-rise building. It's only 40 to 45 meter high. But as you can see, there are multiple levels of open spaces which they want to use as like an open air meeting and things like that. So they want to make sure that people can relaxedly sit on those open air terraces and they can work. They should be able to conduct meetings in those locations. So for that, what we do is we try to identify the wind speeds at all those locations by doing a pedestrian level wind study, and then trying to find out which are the areas which are like having an issue from a wind point of view. And if we identify certain areas, we try to advise like the mitigation measures and how those wind speeds or wind related comfort issues can be taken care of. Now, one of the most thing I think most of the times I think I get this question all the time when I meet any new clients or new people when I'm trying to give them the ideas of wind engineering, like why we have to worry about wind. So I always have only three reasons. The first one being safety, because as responsible engineers and designers, we are designing structures and we should be very, very careful about the safety of the occupants. So the first priority should be always towards the safety, like to make sure that the structures are safe. Second thing, to make sure that the structures are designed properly, as like whether, irrespective of the kind of technique that we use, the structures should make sure that like our structures should talk about us rather than we being talking about us, right? So with the design process has to be appropriately done. And finally, savings. Definitely, that's one crucial element when it comes to the overall cost of like significant projects. As you can see, I have shown a simple example. When the wind loads are different by 20%, it's bringing in 3 to 5 million USD on the picture. So you can identify the kind of cost difference that a whole project will have by accounting the actual wind engineering techniques. So I hope I didn't take much time. So my closing thoughts are like, wind engineering is a new field. It's a very niche field which comes under civil engineering, but it's very, very crucial when it comes to design of high-rise structures. And people who are interested in the design of high-rise structures should definitely pay attention to the wind engineering techniques. And I'm 100% sure that by properly applying the wind engineering techniques, you can definitely bring a big change to the overall design of high-rise structures. So with that, I conclude. And if you have any questions, I can answer. Thank you. Any questions?
Thank you. Thank you, Rahul. It's a real insight on the wind energy and how it acts with high rises. So we'll come to you for all the towers. Thank you.